Hi, I'm Nazifa.
Hi, I'm Natalie.
And I'm Saida.
And today we're going to teach you integration by parts. So this problem is the integral of e to the x sine of x dx. The theorem for integration by parts is the integral of u dv equals u v minus the integral of v du. Right now what we have is the integral of u dv. So we can use this to figure out what u and dv is. In this case, I said u is sine of x and dv is e to the x dx. You can switch these values, but you have to make sure that the dx is in the equation of dv. Then, if you look at the theorem, you know that we also have to find du and v. So to find du, we take the derivative of u, and we get du equals cosine of x dx. And then to get v, we'd have to integrate the dv equation, and we get v equals e to the x. When we plug in those values back into this theorem, we would get sine of x times e to the x minus the integral of e to the x cosine of x dx. This problem is a little complicated because we have to use this theorem not once but twice in order to simplify this integral. So in this second time we're using it, we say u is cosine of x and dv is e to the x dx. Again, just make sure that your dx stays with your dv equation. When we take the derivative of u, we'd get du equals negative sine of x dx and v equals e to the x. To get v, we have to take the integral of dv, just like we did last time. And now, again, we would use these values and plug it into this equation. So first we have to bring down this side, so you get sine of x times e to the x minus, and then I just put parentheses, and you'd plug in this here, so you'd get cosine of x times e to the x minus the integral of negative e to the x sine of x dx. The thing is, with this problem, you have to remember what this is equal to, and on this side, I didn't write it because it would take space, but this is equal to this, so I'm going to write it right now. The integral of e to the x, I'm going to rewrite the same problem. The integral of e to the x sine x dx is equal to, for here I just put the e to the x to the front, e to the x sine of x, and I distributed the negative into the parentheses. So you get minus, again I put the e first, e to the x cosine of x minus, here you have a negative and a negative, so that would be positive, and then you have a negative right here, so that's why it ends up being negative, minus the integral of e to the x sine of x dx And here's where we put plus c, because your final answer has to have plus c. If you've noticed, we have this value right here, but this value is the problem itself. It's right here as well. So what I did was I added, because this is negative, I added, because this value and this value is the same, I moved this to that side by adding. So you get 2 times the integral of e to the x sine of x dx equals e to the x okay, I also did 2 steps at once. You get e to the x, and what I did was I factored that out, so you get e to the x times sine of x minus cosine of x. And you have to remember, this is what we're trying to solve for. So you divide by 2 on both sides. And don't forget your plus c. I do that a lot. And your final answer would be e to the x times sine of x minus cosine of x over 2 plus c.